Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to look at functions. What is a function in math? A function is a rule or a relationship between two sets that maps or assigns exactly one output for each input. It's also called a mapping. So there's two sets, and one set has the outputs and the other set has the inputs. And for each input, there is exactly one output. Let's look at some examples. Here's an example, and this set here is my set of inputs. There's three elements there, three things, and this is my set of outputs. Again, there's three things there. So these are the inputs, and these are the outputs. We see that bedroom is mapped to lavender, kitchen is mapped to sand, and living room is mapped to yellow. So each room has its own color. This is a function, because for each input there is one output. Now, how about this example? Is this a function? We just need to check that is there an output for each input, and exactly one output. Again, these are the inputs, and outputs are here. So for each input, each room, is there a color? Yes, each room has one color. Now, what about now? I'll add one more arrow. Is this a function? This one input has two outputs. Living room is both sand and yellow. So therefore, it is no longer a function. It is just a relationship between elements of two sets, but not a mathematical function. What about this? Is this a function? Does each input have exactly one output? Well, no, because there's one input with no output at all. Living room has no color assigned to it. So therefore, this is not a function, but I could make it one. Let's say I assign living room to be lavender. Now it is a function. We have here a table depicting the cost of grapes. And is this depicting a function? We have inputs here, they are weights or masses, and then output is the cost. So 1 kilogram of grapes costs $4, and 2 kilograms costs 8, and so on. We notice here that 4 kilograms costs 15 and also 5 kilograms costs $15. Is that the problem? No, it's not a problem, because for this to be a function, all that is required is that for each input there is exactly one output, and that is satisfied. It does not matter that some of the outputs are the same. But this here, 10 kilograms, does not have an output. There's nothing here, basically unknown, so that makes it not a function. If I want to make it a function, I need to put here something, some cost. Let's say $30, we double this here. Now it is a function. And here's some more terminology. Now that it is a function, we can talk about the dependent and independent variable here. The weight is called the independent variable. You can talk about any weight there is, okay? And the cost, the output, is the dependent variable. It depends on the weight. All right? Another thing we say in this situation is that the cost is a function of weight. Now that our table is a mathematical function, then we say that the cost is a function of weight. The dependent variable is always a function of the independent variable. What about in reverse? If we were to reverse the inputs and outputs here, is it still a function? In other words, is weight a function of cost? If these were the inputs, then is there exactly one output for each input? We see this input here, 15, has two outputs. 15 is mapped to both 4 and 5. So no, it's not a function there. All right, now let's look at a graph of a function. And let t be the function that maps a number x to its square, x squared. Make a graph of t for integer values of x from -3 to 3. All right, I'm gonna make a table first and list these values. So I have x and then x squared. And x goes from -3 to 3. And x squared, okay, -3 times -3 is 9. -2 times -2 is 4 then we get 1, 0, 1, 4, and 9. And now we will treat these as ordered pairs. So they become x and y coordinates, ordered pairs for the coordinate grid. And that way we get the graph of this function. For example, -3 and 9. It's this point, -3 and 9 over here. An ordered pair, x and y coordinates. Then -2 and 4. Then -1 and 1, 0, 0. And then it is a symmetrical function. I get all of these. I could even calculate -4 and its square, which is 16, and add those points there. So there we have a graph of this function that maps x to x squared, okay? And you will study this more in algebra. If I actually drew it in as a curve, we would get a parabole. Now note here, we have these ordered pairs. And so the function actually consists of these ordered pairs. And a function can actually be given as a list of ordered pairs. That's one way to give a function. Another way is, as I did here, I explained that x maps to x squared. You could also have x mapping to, say, 2x minus 5 minus 6 over x, or some other calculation like that. All right, B says, if you reverse the inputs and the outputs, is the resulting relation a function? So if we consider these to be the inputs and these to be the outputs, then is it a function? Remember, for a function, we need that for each input there is exactly one output. If these are the inputs, then I have, for example, here I have 1 and 1. This is the same input, and it maps to two different outputs. So no, it's not a function then if we reverse the situation. Okay, this is all, and I hope it was helpful.